November 14th, 2024. A standard data packet arrives at the Jet Propulsion Laboratory in Pasadena. It was supposed to be weather data. Instead, the file contained a chemical signature so bizarre, the lead analyst assumed the rover's sensors had suffered a catastrophic failure. But the sensors were fine. NASA had just found something on Mars that, according to our understanding of the universe, is impossible. For decades, we've been told the red planet is a rusty, frozen corpse, a warning of what happens when a planet dies. But this new data suggests we've been looking at the graveyard, while ignoring the ghosts walking right past us. We aren't talking about ancient fossils or frozen bacteria from a billion years ago. We are talking about a biological engine that is active right now, creating signals that we can finally hear. If verified, this discovery breaks 3 laws of planetary geology. It rewrites the history of the solar system. Forces us to ask the terrifying question: if life is there, why has it been hiding from us? NASA is being cautious. They call it an anomaly, but the raw data tells a much more violent story. Today we open the file. We look at the chemicals, the patterns, and the impossible isotope that shouldn't be there. Welcome to the new Mars. It's not dead, it's just sleeping. And we just woke it up. To understand why this finding is impossible, you have to understand the dead planet dogma we've lived with since 1976. The Viking landers ran tests. They pour nutrient soup onto Martian soil, and strangely, the soil reacted. It fizzed. Scientists shouted, "Life!" for about 5 minutes. Then, the other instruments checked for organic molecules and found absolutely nothing. The consensus shifted. Mars soil wasn't alive, it was just chemically aggressive. Like bleach, it killed everything it touched. This became the perchlorate problem, a blanket explanation for everything. Gas release? Perchlorates. Weird readings? Perchlorates. We stopped looking for life and started looking for rocks. Geology took over. Mars became a history lesson, not a biology lab. Until 2019, the Curiosity rover was sitting in the Jezero Crater when its tunable laser spectrometer picked up a ghost, methane. Massive feathers of it, surging by 1,000%, then vanishing completely within days. Here on Earth, 95% of methane comes from biological activity. Cows, termites, rotting vegetation. It is the breath of life. On Mars, it shouldn't be there. The sun's UV radiation destroys methane in roughly 300 years. Meaning? Something is producing it now, replenishing the supply, pumping it out from the dark below. NASA was intrigued, but skeptical. It's probably just rocks grinding together, they said. Serpentinization. It was a safe bet. Until the seasonal data came back. And the rocks, well, rocks don't own calendars. The methane levels rose in the summer and fell in the winter. Like the planet was taking a long, slow breath. Geological processes don't care about seasons deep underground. But biology? Biology follows the heat. This was the first crack in the dam. But the real flood? That came from a sample labeled tantalum. Enter the Sample Analysis at Mars team, or SAM. They aren't looking for aliens, they're looking for weight. Specifically, the weight of carbon atoms. Carbon-12 is light, carbon-13 is heavy. Life loves the light stuff. Living things are lazy. It takes less energy to bond with carbon-12. So, if you find a pile of carbon-12, you find life. Curiosity drilled into the rock at Jezero Crater. It heated the powder to 800 degrees Celsius and sniffed the gas. The results were so skewed, the team stopped the rover. They ran the test again and again. Nearly half the samples were depleted in carbon-13 and enriched in carbon-12, a signal strikingly similar to ancient bacteria on Earth. Christopher House, a lead scientist, put it bluntly. On Earth, this signal would show that microbes were consuming methane. This was it, the smoking gun, the chemical signature of a biological ecosystem. But remember where we are. In space, extraordinary claims require extraordinary evidence, and NASA wasn't ready to commit. They needed to rule out everything else first, Could it be cosmic dust? Could it be UV light reacting with CO2? They simulated the cosmic dust theory. The math didn't add up. You'd need a dust cloud 100 times thicker than anything ever recorded. They looked at UV light, but that process creates a different chemical fingerprint. It didn't match the sample. Every non-biological door was closing. The impossible conclusion was becoming the only logical one left. And then, Perseverance found the final piece of the puzzle in the Jezero Crater. The Sherlock instrument scanned a rock named Wildcat Ridge. It found organic molecules, not just simple ones, but complex aromatics, the building blocks of cell membranes, and they were concentrated in sulfate minerals. On Earth, sulfates act like time capsules, preserving ancient DNA for millions of years. So we have the fuel, methane. We have the building blocks, organics. And we have the signature, carbon-12. By all legal standards of evidence, the case is closed. Mars has life. But science isn't a court of law. It's a torture chamber for ideas. And the critics weren't done yet. Because there is one massive, glaring problem with the life theory. A problem so big, it keeps astrobiologists awake at night. If there is so much life producing all this methane, where are the bodies? We have the smoke, we have the heat, but we cannot find the fire. And that missing fire suggests something even stranger is happening. To confirm the rover's findings, NASA turned to the eye in the sky, the Trace Gas Orbiter, a satellite built specifically to sniff out methane. The rover down below was screaming, "Methane spike!" The orbiter up above looked at the exact same spot and saw nothing. Zero. Not a trace. This wasn't just a discrepancy. It was a scientific impossibility. Physics doesn't work differently at different altitudes. The critics pounced. They claimed the rover had farted, that the methane was just gas leaking from the rover's own wheels. The data was dismissed, the discovery ignored. The life on Mars theory was dead in the water. Again. But the Curiosity team refused to quit. They knew their machine wasn't broken. So, they changed the question. If the rover sees it, but the orbiter doesn't, what happens in the middle? The answer was terrifyingly simple. Something is eating the methane. Fast. Before it can rise high enough for the satellite to see it. This implies an active, aggressive chemical cycle that we have never seen before. Or, it implies a localized wind. Imagine you are standing in a desert. You smell smoke for 10 seconds. Then it's gone. What does that tell you? It tells you the fire is closed. And it tells you the fire is small, just beneath your feet. This realization saved the data. The rover wasn't wrong. It was just standing directly on top of the chimney. So, we are back to the impossible. If the chimney is active, what is the engine? We have to go down. Deep down. The surface of Mars is a radiation-soaked hellscape. Nothing survives there, but life finds a bunker. To understand Mars, we need to look at the dark biosphere of Earth. Places where the sun never shines. 2 miles beneath Canada, scientists found water that hadn't seen the surface for 1 billion years. And inside that water, things were moving. These microbes don't need sunlight. They don't need oxygen. They eat rock, literally. It's called radiolysis. Radiation from the rock splits water molecules into hydrogen. The bacteria eat the hydrogen. It is a nuclear-powered ecosystem, independent of the sun, independent of the surface, and it can last forever. Now, look at Mars again. It has water underground? Yes. It has radioactive rocks? Yes. It has no tectonic plates to recycle the crust. That stagnant crust is a feature, not a bug. It means the deep aquifers on Mars have been sitting there, undisturbed, for 3 billion years. On Earth, the deep biosphere contains more biomass than all the humans and animals on the surface combined. Think about that. The main event of life on Earth isn't us. It's the slime in the basement. So why do we assume Mars is dead? Just because the roof is empty doesn't mean the house is vacant. This brings us back to the carbon-12 anomaly. The rover didn't find surface life. He found the trash. The methane and the carbon isotopes are likely burps, occasional releases from a massive pressurized system miles below, and this changes the definition of impossible. It's not impossible that life exists there. It's impossible that it doesn't. The conditions are perfect, the ingredients are there, the time has been sufficient, but if there is a massive ecosystem down there, why hasn't it evolved? Why hasn't it crawled out? Because it doesn't want to. The surface is lethal. The underground is paradise. They are trapped in paradise. This leads to a theory called the separated sibling. Mars and Earth started as twins. 4 billion years ago, life likely started on both. Maybe it even swapped rocks. Meteorites trading DNA. But then, Mars died. The atmosphere vanished. The oceans freeze. Life had two choices: go deep or go extinct. The life we found traces of, it's the descendants of the survivors, the ones that dug the deepest trenches. And here's where the impossible data gets truly wild. The chemical complexity isn't simple. The organic matter found in the sample is consistent with diagenesis. That means it's been processed, cooked, changed. It implies an evolutionary chain, not just slime, but an ecosystem. Predator and prey. If there is a food chain, there is competition. If there is competition, there is evolution. For 3 billion years, while we were growing legs and building cities, they were down there, becoming something else. We always picture aliens as little green men, but on Mars, the dominant life form might be a global, subterranean neural network of fungus, a hive mind made of slime. And the methane spikes? That's not random. That's a signal. NASA hasn't confirmed this. They can't confirm this, because recognizing it breaks the planetary protection protocol. If we admit there is a complex biosphere, we are legally forbidden from touching it. We have to stop the rovers. We can't drill. We can't sample. We can't risk infecting them with our Earth germs, or vice versa. This is the paradox. The moment we find life is the exact moment we must stop looking at it. But there's a loophole, a sample return mission, bringing the impossible dirt back to Earth. NASA is planning this right now, the Mars sample return. It sounds like a triumph of science, but some biologists are screaming, stop. They call it the ultimate biohazard, because if that sample contains the impossible biology we suspect, opening it on Earth is like opening Pandora's box. We aren't ready for a biology that eats radiation and breathes rock. It would look at our concrete cities and see a buffet. This isn't science fiction. It's a genuine planetary defense concern called back contamination. Carl Sagan warned us about this in 1973. He said, "We cannot take the risk of introducing a Martian plague to Earth. Martian life has evolved to survive radiation, zero oxygen, and toxic salts. Our immune systems have zero defense against that toolkit. If we bring those samples back, they don't go to a normal lab. They go to a BSL-4 facility, the highest security on Earth. But accidents happen, filter break, seals crack. And unlike a virus, these things eat minerals." The International Committee Against Mars Sample Return argues we should study it there, on Mars, remotely. But the scientists say, no. A robot can't feel. A robot can't improvise. We need human eyes on that sample. It is the ultimate gamble. Risk the biosphere to understand the biosphere. Curiosity versus survival. And while we argue, the rover keeps driving. It keeps collecting. The tubes are already waiting on the surface. The plan is set. The European Space Agency and NASA will launch the retrieval mission in the late 2020s. Unless the politicians kill it. The budget is ballooning. The risk is high. The impossible find might stay stranded forever. But stopping now would be a tragedy, because this isn't just about bugs, it's about the great filter. If life started twice in one solar system, it means the universe is teeming with it. It means we aren't special. But if that life always stays single-celled, it means the jump to intelligence is the hard part. Finding slime on Mars implies the galaxy as a garden, but a garden without gardeners, just weed. Regardless of the risk, the discovery changes us. It shatters our cosmic loneliness. For all of human history, we have looked up and asked, is anyone there? The answer, hidden in a few milligrams of carbon on a rusty neighbor, seems to be yes. But it's not the answer we wanted. No radio signals, no cities, just the quiet persistence of survival. It forces us to look in a mirror. We are the impossible ones. We are the anomaly that built spaceships. Mars shows us what Earth could become if we fail. A dead surface, a hiding biosphere. But it also shows us that life is stubborn, that it refuses to be extinguished. The scientists at JPL aren't sleeping. They are rewriting the textbooks. Biology 2.0. We used to look for life as we know it. Now, we are looking for life as we don't know it. This discovery bridges the gap between geology and biology. Rocks and life aren't separate. They are a cycle. And if rocks can come alive on Mars, they can come alive on Enceladus, on Europa, on Titan. The solar system isn't empty. It's just waiting for us to dig deeper. We are standing on the precipice of a golden age of astrobiology. Or a golden age of contamination. The choice is ours. Do we grab the sample? Do we open the box? We must. Because the only thing scarier than life is never knowing if we were right. In the next 10 years, we will see the Mars sample return touch down in the Utah desert. We will see the headlines. We will see the panic. And then, we will see the truth. NASA's impossible finding is just the first sentence of a new book. The methane spikes are a heartbeat. The carbon is a fingerprint. Mars is calling out to us. It's saying, I am still here. I am still fighting. Come find me. And when we do, we might finally understand our place in this impossible universe. Until then, the rover sits on the ridge, watching the seasons change, listening to the gas hiss from the ground, waiting for the day we come back to pick up the mail. What do you think? Is the methane biological, or is Mars just fooling us again? And if it is life, should we bring it back, or leave it alone? Let me know in the comments. The best theory gets pinned. And if you think Mars is weird, wait until you see what we just found on Venus. And thanks for watching.